Hi, this is Mr. Carmody, and we are going to talk a little bit about what is Gateway to Technology and what is Introduction to Student Tech Support Services. So Gateway to Technology is part of the Project Lead the Way system of courses. It's a national organization that San Diego Unified uses as their STEM curriculum. So it's about, basically it's an engineering curriculum. It's offered at a number of high schools inside San Diego Unified, and if you complete 3 courses in the high school, you will get guaranteed admission. If you fulfill a number of other pretty basic requirements, you get guaranteed admission into San Diego State's engineering program, which is a real benefit. So, anywho. What do we do in GTT? So GTT is basically, it's an engineering course. So just the way that you would study in science, you'd study the scientific method. In GTT, you're going to study the design method, basically, design method. And while in some of your other courses you've engaged in types of thinking that are convergent, that means that you're arriving at a specific answer. In design, you're engaging in both convergent and divergent thinking. So you're using technical skills that you acquire to be creative and arrive at solutions to satisfy people's needs and wants. That is what design and engineering is. So what do we actually do in class? I'm going to show just a couple of different examples. So in just a second, you're going to see a video of me showing Autodesk Inventor. That's the design software we use. I'm also going to be showing Robot C. So the main two things that we do in class is we learn the design process. We learn, and along with that, we learn to operate Autodesk Inventor, which is a 3D modeling software. And then we're going to also learn robotics, and with robotics we learn programming. So we learn to program in a language called Robot C. So let's go ahead and let's take a look at, first of all, this is me demonstrating Autodesk Inventor. So let's take a look at this video. Hi, this is Frank Carmody. So today we're going to take a look at creating a little bit of more complicated assembly, and we're going to be creating all of the IPTs from inside the assembly. So let's go ahead and create a new assembly. Okay, so we're inside an assembly. The first thing we're going to do is to click Create. Okay, we have to actually name our part file. Okay, so we're going to name this our wheel rig, I don't know, for lack of a better name. Okay, then we have to go ahead and just click to place. And now notice in our browser bar we're actually inside of this wheel rig IPT. So we're going to go ahead and create a 2D sketch. Okay. And the first thing we're going to create inside this 2D sketch is actually kind of a shell which will hold our wheel later on. So now usually we would specifically not start on the origin. In this case we are. So we're going to go ahead and create a circle. We're going to dimension that circle to be 2 inches. Click the green check. We're going to scroll out to zoom. Then we're going to create a line to cut this circle in half. Okay, so the line connects down. We're going to right click OK. Now we're going to click trim, and we're going to trim off half of the circle there. Okay, notice that the dimension line still goes out, but that's fine. Right click OK, right click Finish 2D Sketch. Now we're going to go ahead and revolve this this half the circle. So we click once to select the profile, once to select the axis. We're going to change from full to 180, and it automatically changes to be 180 degrees. We're going to go ahead and click the green check, and now we're actually going to create a shell from that half circle. So we're going to go ahead and click the shell. We're going to make this shell, we want to leave 1/8 of an inch, so we can actually just use a fraction in this case. We're going to put 1/8 of an inch. I'm going to click a green check, and now shell. Okay, so by creating this on the origin, what we've done is we've allowed ourselves to actually kind of predictably work from the middle of the object. So we're going to go ahead and we're going to click the plus for origin, And we're going to go ahead and create a work plane right in the middle of our object. So we click on the XZ. It depends on how you drew your original drawing, but in my case, the plane in the middle of the object is the XZ plane. It may be different on yours. So we go ahead and we create a work plane. So we click on plane. We get to our XZ plane from the origin. We just jiggle it, take the yellow circle, jiggle it a little. We want a 0 amount offset. We'll click the green check. Okay, so now we have our work plane. Now we're going to create a 2D sketch. We click Create 2D Sketch. We click on our work plane, and now we have a sketch that's living directly in the middle of our shell. Okay, so now what we want to do is we want to create this kind of holder for our wheel. So we're going to go ahead, we're going to go back to the origin because we know right where that is, right? When we highlight over it, we can see our cursor changes to green. We're going to create our initial circle, and we want to make sure that that circle is 1 inch. So we're going to go ahead and dimension it to 1 inch. Okay, so that's our initial circle. Now we're going to go ahead and we're actually going to draw in the rest of this holder here. So we're going to kind of drag over. Now, one thing that will really help us out here is by changing the view options. So let's go to view. We're going to go to visual style, and we're actually going to change to shaded with hidden edges. Okay, so this kind of lets us see through the objects and still have the shading there to help us. I think it's a good mix. So let's go back to the sketch, and we're going to go ahead and we're going to create a spline. We're going to kind of choose a point that's not the outermost point of the circle, but kind of inside here. And we're actually just going to create a spline up and create kind of this nice shape. Click the green check. We're going to do the same thing on the other side. Okay, we're going to choose just kind of this point here. We're going to create this kind of nice shape up. And click the green check. Now we're going to connect those with a line. Okay, and we're going to create this kind of free form shape that will flow nicely. Right click OK. And then we're going to go ahead and just apply a nice constraint to this line just to make sure it's kind of a 0 degree offset from the, oops, Control Z because it, and it looked vertical to me, but it is horizontal. So let's go ahead and click horizontal. Now we have kind of this nice straight line at the top here. Alright, so we're going to go ahead and trim off part of the circle that we don't need. Then we're going to right click Finish 2D Sketch, and now we have this, this sketch living in the middle of our shell. Okay, so we're going to go ahead and extrude that sketch. We're going to make it a 1/4 inch total depth, and we're going to make it extrude symmetrically from the original drawing. Okay, so we have kind of this nice holder right in the middle there. Alright, we're going to go ahead and click the green check so our shape is kind of coming together, or our part is kind of coming together nicely here. We're going to go ahead and create another sketch on the same work plane that we already have. Notice that the origin is still right in the middle of my circle, and we're going to kind of create our pegs that are going to help us to attach our wheels later on. And we're going to make those a 1/4 inch, oops, a 1/4 inch in diameter. And click apply, or click the green check. So now we have our drawing here. We're going to right click, click OK, and right click and finish 2D sketch. Now I actually want to go back. I wanted to make this, I made this a little bit too thick here. So we want to make this middle part, we actually want to change that to be, instead of a 1/4 inch, we want an 1/8 inch here. Okay, so there we have it. Then we're going to go back to our sketch 3. We're going to extrude this out. Oops. And I clicked the wrong thing. Click extrude it out. So we only have one profile here. So we're going to actually extrude this a 1/4 inch in either direction. So it's going to be a 1/2 inch total. Okay, we're going to extrude that symmetrically. And notice it's really nice here because we can see everything with that view setting. So we can see that it's coming out correctly. Click the green check. We're going to right click Finish Edit, and now we're back into our assembly. So we right clicked Finished Edit, and now we're into our assembly. We do have a work plane here. We can set that as invisibility to 0 if we want to, or we can keep it as is. For now, let's just go ahead and keep it as is. Okay, so now we're going to go ahead and create a second part. We're going to click Create, and this time we're going to call this Lesson 13. We're going to just call this Wheel. We're going to click OK. All right, now what we have here, we still have our work plane visible, but we want to work off of our other sketch. Whoops. We want to work off of this other sketch. So what we're going to do is we're actually going to do something. We're going to first create a 2D sketch that's going to live right on our work plane. We get a work plane of our own, but we can go ahead and create it right there. And notice where that work plane lives. It lives right in the middle there, right in the middle of our original sketch. And we're going to actually get out of here. Finish 2D sketch, finish edit, and we want to go back in and we actually want to take this work plane. We're going to double click to get back into our original drawing, and we're going to right click on the work plane, and we're actually going to, we're going to right click on the work plane. We're actually going to uncheck visibility so it doesn't get in our way. We're going to edit, did the wrong thing. We're going to right click, finish edit, and now we're back out. We're back out into our original assembly. And we can just double click back into the wheel. Okay, so now we're in the wheel, and we're going to double click back into sketch 1. Okay, so now we're kind of back into sketch 1. So we want to use this geometry from the other part. Okay, now we can't use it because it's not part of this part, but what we can do is we can do what's called project geometry. So we can actually go in and select something we want to work off of, in this case the center of this nub here. Okay, and we can actually click on that and right click OK to get out of the tool, and now we have that circle that we can work off of. So notice that that's the circle at the base of that kind of nub we're going to attach the wheel to. And now having that to work off of, we can go ahead and click the center point. We can bring this out, and we're going to make this circle 1.5 inches. And click the green check. And now we're going to create a line. Let's look at it straight on. So we're going to create a line. We're going to cut this in half. Right click OK. Then we're going to trim off half of that circle. So we're kind of doing the same thing we did for the shell. Right click, finish 2D sketch. Now we're going to go ahead and we're going to revolve that 180 degrees to get our wheel shape. Choose our axis. So we chose the profile. Now we're going to go ahead and choose the axis. Okay, and it's not full. We only want to go 180 degrees. Click the green check. So now we have kind of our wheel, but it doesn't have a hole to attach anything yet. So we're going to go ahead and create a 2D sketch. So we clicked on 2D sketch, click on the surface of the wheel. And once again, we're going to project geometry through. Okay, so that's that center of the nub there. We're going to create a circle of the same size. Okay, so we clicked on the circle tool, we clicked in the center, clicked again on the edge of the circle. We don't need a dimension because it's based upon the original geometry. We could dimension it, but the dimension will just come out as 0.25. And notice that it gives it the over constrained, right? So we click cancel. That's because it's already based upon that projected geometry. Okay, right click, finish 2D sketch, and now we're going to extrude. Okay, so we're going to extrude cut. So we choose cut. We want it to go in 1/4 inch, and we click the green check. Okay, so there we have our part, and we can kind of see it right there. All right, so we're in here. Let's go ahead and we're going to make our we're going to change it from our default. Oops. We're going to change it from our default, and we're actually going to make the circle kind of a gold metal. Okay, right click, right click, finish edit, and now we're back into the part that we were before. We're going to double click the assembly to get back into the assembly, and then we're going to double click our wheel rig to get back into the wheel rig, and we also want to change that. We want to change that to a different, let's say we change it to nickel. Okay, right click, finish edit. Okay, so now we kind of have our assembly finished here. Or we have our two parts finished. Okay, so let's go ahead and we're going to save this back off. And when we save, what we get is we get this option. We get asked what we want to call our assembly, right? Okay, so we want to call our assembly lesson 13 assembly. Okay, and we're going to get the second dialog here when we save. Okay, now this is asking us, do we want to save the IPTs? And we do. So we want to do yes to all, and we want to click OK. And so now that allows us to go ahead and save. We just went ahead and saved all of our IPTs off. Okay, and notice that it was created, notice that it automatically created a constraint here, a flush constraint. So we can edit that flush constraint. We can actually change the offset of that, and we're going to do 1/16 of an inch offset. Okay, to kind of move that out. Okay, we want a little bit of space between there. Okay. Oops. Okay, small amount of space. Let's actually go back in there and we're going to change it 1/8 of an inch so you can see. Okay, so we're going to actually move that off. And you can see now that it has some space between. Notice that we're right up against the outer wall there, so we're actually going to reduce that back down to 1/16, and that should be just right there. Okay, now we're going to go ahead and place a second component. Okay, and we want to place our wheel again. Okay, just going to place it right there. Right click OK. We're going to constrain it. So we're going to mate, and we're going to mate it up to this central part here. Click apply. And then we're actually going to mate the center lines of the hole and the nub. So we have our, we're going to have to zoom in. We're going to mate the center line of the hole, swing around, and we're going to mate the center line of the nub, and click apply. Okay. Then we're going to go ahead and we're actually going to edit this mate here. Okay, we're going to. That's going to be a 1/16 of an inch offset as well. And we're going to click apply. Okay, so notice we have our finished, whoops, there was my problem. Okay, we want a 0 amount mate. Oops, sorry about that. So we want a 0-inch mate off that. We're going to bring it right up. We could do a 1/32 if we really wanted to. 1/32, and that would bring us just a tiny bit. So then we have a 1/32 on both sides. And we could do that here on the flush as well. So if we wanted we want to add another 30-second onto that. Of course, we do 3 30-seconds. Oops. 3 30-seconds, and click the green check, and that gives us an exact perfect match. Okay, so there is our assembly all completed except for one last thing, of course, and we're going to do the material. And we're going to go back to the material, and we're going to do this as gold as well. Okay, so there is our finished assembly. Okay, so there was an example of a little bit more complicated assembly, and we've created all the IPTs from within the assembly, which creates much more quick work. It's a little bit cleaner because you're just creating everything from one interface. Of course, it uses heavily from the browser bar. So let's go ahead and we're going to save this. It's probably going to give this the option to save that additional IPT, but oop, no, it didn't. Okay, we're all saved off. Go ahead and try to create the same thing on your own. Good luck. Okay, so that was introduction to Autodesk Inventor. So I hope that was interesting for you. That is you know, every single person that takes the class learns to draw similar to that. So it's very, very interesting. Hopefully next year we'll have a 3D printer and we'll be able to start to print off some of these great designs we have. Also, now the Autodesk Inventor then fits in with VEX. So the VEX robotics kits are used in competitions throughout the United States. And starting next year in 2014, we're actually going to be using Autodesk Inventor to then, the skills that you've developed in Autodesk Inventor to then design VEX robots, the physical portion of the VEX robots, and then to actually program in Robot C to have the robots, act intelligently, to take in data from sensors and then to act upon that data by controlling servos and motors on the robots themselves to achieve particular goals or to fill some particular challenges. So let's take a look at somebody writing Robot C.
Hello guys, this is Tim here. I'm creating a quick video so you guys can connect, you can download the firmware to the VEX microcontroller, and our objective is to control the speeds of 2 motors. Okay, so what I want you guys to do is get your battery connected to your VEX Cortex, and then I have 2 motors here. I'm using our standard motor. I'm connecting it through a motor controller, and I have them connected into ports 2 and 3. Now make sure you have it connected to the motor section, and then I have a type A to type A USB cable. Okay, so on your computers we have a program called Robot C. Now I'm going to see if I can find it here. Innovation first. No, that's not it. Robot C, here we go, and I'm going to click on that. And let's see what comes up. Here we go. So your VEX Cortex is connected. What I want to do now is download the firmware. So the existing firmware on it is a VEX firmware, but what we need is the Robot C firmware. So what you're going to do is you're going to go to Robot, you're going to click on Download Firmware, and then I want you to click on Automatically Update VEX Cortex. What does it say? It says this utility will automatically detect your VEX Cortex and update it to the latest firmware versions. If you don't do this and you try to download code or C to your microcontroller, it's not going to do a damn thing. So before you proceed, make sure your VEX Cortex is connected via a USB 8A cable to your computer. Now we've done that, so let's go OK. It says master C, OK. Writing Robot C firmware, so it's downloading it. So hopefully this works for you guys. Robot C download was completed successfully. Okay, so now we have the firmware on our VEX microcontroller. What I'm going to do is we're going to create a program. So go to File, New File. Alright, now this is, we're working in Robot C now. Okay, so the first line, it says task main, and then it has an open and closed brackets, and then we have 2 open and closed curly brackets. I'm going to probably explain that later. I might not though. But anyway, so let's go into Robot and go to Motors and Sensors Setup. Alright, now what we're going to do is we're going to click on Motors, and I'm going to call this left motor, and then I'm going to call it now. See, I know I have motors in port 2 and 3, so why am I doing that? I need to put this in port 2, and now I'm going to put one in port 3, and I'm going to call that right motor, and then I'm going to click on this, and this is a 3-wire motor. Okay, and then a 3-wire motor. I want to ensure that these guys can be reversed. Okay, if you don't check that, your motors only turn in one direction. So type in the name of your motor in whatever port you're using. If you have motors connected in ports 5 and 6, you would put it in port 5 and 6 here. You change it to the type. We're using a 3-wire motor, and you make sure that you leave it reversed. And let's go Apply, and then go OK. Now look at this. It says the code automatically generated by Robot C. So what it does is it's creating, what would you call this? Maybe 2 constants. So this is basically telling Robot C that you have 2 motors set up in ports 2 and 3. Okay, so you need to put this in. Now what will we do? We're going to open up Motors, Variables, and I can drag this out. Alright. Now I haven't done this in a while, so I can't even remember. So let's go to help, and let's type in motor, index, and let's type in the motor command and see what comes up. Alright. Okay, motor port 1 is equal to 127. What this does, it's going to turn in a clockwise direction of power 11, 127. Now, let's have a look here. It says for 127 is the maximum amount of power. If we make it 50, it's going to be half that power. If we make it minus 127, it's going to reverse it at full power. Okay, so you'll figure out what speed works. Okay, so let's do this. I'm going to highlight this, and I'm going to press Control C. I'm going to close this down and put this in, and this is port 1. I'm going to make this port 2, and see, does that work? And I'm going to make this port 3. Now, if I save this program, I'm going to save it, and we'll call this, let's save it to the desktop real quick. I'm going to call this Tim's program. Alright? I'm going to go OK. Now, if I run this, what's going to happen is, I'm going to have to download it to the controller first. So let's do that. I'm going to go to Robot, Compile, and Download Program. Alright? And it's telling me, it's after downloading it, and it's telling me that the main battery is not powered on. So okay, I'll turn it on then. And I'll go OK. And I'm going to start this. And it does nothing. Okay? Now why does it does nothing? Because the program runs, it turns the motors on for a millisecond, and then the program ends and it's done. So what we need to do here is add some sort of timing command. So we're going to turn these on and wait for a couple of seconds, wait 1 millisecond. Now if I make this 2000 milliseconds, my motor should run for 2 seconds and then they should turn off. So let's save it. And let's compile and download it, and let's see what happens. I'm going to press start, and my motors are actually running, and now they're started. I don't know, you probably can't see that, but hopefully you can hear it. They run for 2 seconds. I'm going to do it again, and this stop. Okay? Now, I think that's enough information for you. Okay, so I'm going to finish the video, and you guys are going to see if you can follow along and do it yourselves. Okay, good luck.
Okay, so that was Robot C. So those are the two main things that we do in GTT. So along with the actual VEX building. Now the VEX building of the actual robots, we're going to take a look now at some of the things that people do at other schools. Remember that these are the only thing that we do in GTT. These are the two main activities that I've covered here. We do, and additionally, we cover a lot of basic engineering vocabulary. We cover a lot of design vocabulary. We cover a lot of design process. And we also throw in things like our paper decathlon, which is a weekly engineering competition that we do in class. So we kind of mix it up with, but these are the two, the Autodesk Inventor and the VEX Robotics are the two main activities in the course. And also know that you can do it 2 years. So by doing it 7th and 8th grade, starting next year, basically you won't repeat any activities. You will 8th grade will be an extension of what you learned in 7th grade. So it'll be an opportunity for you to do more project-based work, and take your skills to kind of the next level in 8th grade. And we have good success. So sign up now. Okay, so let's take a look at what some other schools around the country do on PLTW, Project Lead the Way classes in high school and in GTT, and along with some of the VEX. Now we don't do VEX competitions, but we do exactly the same thing. It's the same VEX setup. So let's take a look at what some other schools are doing.
I mean, a lot of them are used to like remote control things where it's already built for you.
Right.
Here you're building it from ground up, so that'll be very beneficial.
So they get the overall view instead of just the finished product.
Exactly.
Okay,
Just
excellent.
playing with it, they actually get to build that.
And is this the Vex Inventor set, or? Okay.
My name is Dave Hoffman, and I run the engineering program, Engineering Academy at River Ridge High School. Started the academy about 2.5 years ago. We use Project Lead the Way as our guidelines for this program. And with Project Lead the Way, they've been around for about 10 years, have about 6,000 high schools and middle schools nationwide as part of the program. So the program that we're teaching here is a national program. It's not just a local program. And what that means is that kids can actually get college credit for the courses nationally. In the last 2 years, we've been able to add an Introduction to Design course. Second year course is our Computer Integrated Manufacturing and Robotics. And we're in the process of adding Aerospace Engineering for next year. There will be a 4th course that we'll add, which will be a self-paced course. This is a 4-year program, and so kids have to pass the previous year to move to the next year. In the last 2 years, we've been able to make some pretty great strides in the program. We have gotten all the courses approved for honors. We have gotten an articulation agreement with St. Pete College, and so that all our classes, students can get articulation right to their engineering program and get college credit directly for these courses. We just passed Project Lead the Way certification last week, which means that our students now can apply for and get college credit nationally.
I'm Joseph Spizak. I go to River Ridge High School. I'm in the Engineering Academy here. This year we're messing around with robotics. We have robotic arms in the back room. We have Vex Robotics, which is kit building. We also have CNC machines in here. We do lots of GMN coding, which is just numbers and letters, and then comes out with a finished product. So we have samples of cubes, and we made initials from just putting in numbers in a computer. Okay, so this is my Vex Robotics program. This kit right here is a miniature conveyor belt. It's a project we have in here. It calls for 3 stops and 3 starts, and then we're supposed to transport a part, which this is the part they gave us to transport. We basically put it on the conveyor belt, we press go. It goes till the first sensor, which this sensor is a light sensor. It says, okay, something's in front of me, so whatever the computer program we're writing says, it will probably be stop when you get to the light sensor. And the part will stop, something will happen to it, I don't know, somebody will put something on it, and then they'll put it back on the conveyor belt and push the start button, which is the bump switches. It goes until it gets to this ultrasonic sensor, which it sends out sound waves forward, and when it bounces off an object, it comes in through the other hole. So there's 2 holes here. It gets there, part registers. Again, the computer says, okay, there's a part there. I need to stop. And then somebody will take this off, start up the program again, push another bump switch, and it will go down to here, where it checks in with the limit switch. And then the computer will know there's a part there, and it will fall off into a basket after I make that.
This is one of our newest milling machines. One of the things we try to do is we use business-related software, and we try to use business-type machines. Now this is a very small machine, but it's also used in business. So we can teach students how to actually mill parts on this machine using software that's used in the manufacturing environment today. That way when they leave here, they could get a job in a manufacturer doing the same type of job. This machine over here is one of our flatbed. This is a flatbed router, but this machine we actually can do things like make signs and make very large, flat designs. This is what we call a micro mill. So we would mill very small parts on this machine. Is there anything on that? I don't know if you can even see that, but we mill on wax because it's a lot more forgiving for students, and that way they don't break the bits, and they can make their mistakes. And what I do is I just throw these in a crock pot and remelt it and give them back to them and say, do it again. We teach students about pneumatics and hydraulics, because when we teach them about robotics, that's what drives most of the machines in the manufacturing world, and also drives robotics. This is our new laser engraver, and this thing will engrave on any material including glass, and it does engrave extremely fine detail. And we're actually going to use this machine for our fundraisers when we're going to do like keychains and stuff like that. But again, this actually takes, I could take a picture, or it can take any design out of like a program called Corelware, and then actually put it into the machine, and it will actually engrave that design on material. Metal, wood, glass, just about anything you put in the machine. These are some of the designs that some of our students have done. We start them off very basic. We actually teach them what's called G&M code, which is what the industry uses for programming milling machines. We start them off by doing their initials, and again we use wax because it's very forgiving. And then from there we step up and we actually give them a part to design in the CAD system, and then from the CAD system they run it into a milling program which assigns a milling machine, and then they bring it over to that milling machine, like this machine right here behind me, and then they actually mill the part out. This is our robotics room. In here we actually teach students how to use manufacturing type robots. And we have different versions of those that we teach on. These are called scorebots. These are pretty good sized robotic arms. But these actually simulate the arms that you might see in an automobile factory, that pick up the frames, pick up very large parts, move them around, and the students actually program the arms to do manufacturing functions. We also use what we call mini arms, which are these right here, and these actually do the same function as the large arms. But because we can buy more of these, we can actually have more students programming at the same time. Yeah, we also do some fun stuff in here. This is a robot that actually has a camera built into it, and of course you can see we got different size wheels on it, and we're going to add more sensors to it, so it'll actually be able to run up to a wall, stop a certain distance from a wall, back up, go in different direction. This can be controlled remotely, or we also have a joystick that allows us to control it using the joystick. This is our new computer lab that we set up. This is our second lab, and in here this is our second year class, and we've got all new high-end HP computers, and because most of the programs we run are very graphics focused, so we have to have the latest program and the latest video cards. And the kids do all their design work in here. They actually do their programming work in here on the computer, and then they bring in their, like for an example, the conveyor or the robot. They'll bring it in here, set it on the desk, connect it to the computer, download the program, and then take it out into the room and work it out there. What we try to teach the students here is how to design things on paper. We get them to sketch things first, and then we go into a CAD system which actually allows them to produce blueprints. Again, the idea is that to help them take an idea from their head, put it onto a piece of paper, and then put it into a working document that we can then take and make the part from. This is a type of system we use, Autodesk Inventor, which is one of the industry standards right now as far as a CAD system. A design of a train, and then we take that design from the CAD system and we actually put it into our three-dimensional printer, and it actually builds the part. This is actually one of the examples of one of our trains, And you know, being pink, you could probably guess this was done by one of our female students. We let them be a little bit more creative on the cow catcher. Of course, a lot of students don't even know what a cow catcher is, so I have to explain to them what a cow catcher is. But for some reason, everybody likes spikes. So this is one of their designs. It's made out of like a plastic weed whacker material, but what it does is it heats it up and basically squirts it out like a glue gun, and then actually builds it up over time until it actually makes a three-dimensional part. All the parts then fit together like that. Once they're done, each part is created separately, and then all supposed to fit together. One of the skills that we try to teach the students in the first year is organization skills. That's usually one of the toughest ones to teach new students, especially new high school students. We do this for two purposes. One, because the course is pretty in-depth and has a lot of material to it. Without organization, they're going to have a hard time. The other is, as they become engineers, engineers have to be organized. This is an example of what we call an engineer's binder. And all the students are required to have one of these. And as they do assignments, all the assignments and projects are put into the binder. And this binder then becomes their reference guide. And so, again, that's one of the challenges, is to keep students, to keep this thing updated. Because once they do some of the projects, they actually have to refer back to this binder. One of our seniors has just got accepted to the University of Florida in their engineering program, and has, along with his academic Bright Futures scholarship, has received $30,000 in additional scholarships for the engineering program. So that's the kind of thing we're trying to get our students to understand, is that once they get through the 4 years and they do well in the program, they can pretty much write their own ticket. There's a big push in our program to recruit girls and minorities, and I try to make them understand that they probably have a better road to success, just because colleges have the same issue we do in trying to get girls and minorities into the program. So again, we have an active recruiting program going. We can always do better. That's the challenge.
With technology becoming more and more important, there is a growing need for engineers in America. The number of science and engineering bachelor's degrees awarded in the United States is trailing behind other countries, accounting for only 11% worldwide. Cal Poly Pomona is a regional training center for the national nonprofit organization Project Lead the Way that targets middle and high school teachers. This project is part of an effort to advance and improve education in science, technology, engineering, and math, otherwise known as STEM. These disciplines will then be introduced and taught to their students.
What was really interesting for me to see this year, because it was the first year that we had it, was the students coming in not really knowing much about engineering. This program allowed for tons of engineers in our community to come in and work with the kids, to speak to them, to see what they were doing in the classroom.
In teaching our Project Lead the Way last year, the students were so excited for every project. Every day was like, what are we going to do today? And it was just really exciting to see students working together, asking questions.
Cal Poly Pomona's partnership with Project Lead the Way, or PLTW, is part of a commitment to advance education in STEM disciplines. PLTW is the leading provider of STEM curricular programs in the U.S.
One of the reasons why students do not select engineering is because they just don't know what it is. They've never heard of engineering, and a lot of teachers in the K-12 system also do not know what engineering is. Through Project Lead the Way, teachers are exposed to the field of engineering. They become more familiar with what engineering is all about, and they can convey a sense of creativity and excitement from themselves to their students.
To create interest in engineering and to prepare younger students for STEM fields, Cal Poly Pomona has become the largest regional training center for PLTW in California. With PLTW's innovative concept, Cal Poly Pomona is able to inspire and engage K-12 students in the engineering field at an early age.
Early exposure to engineering is really key for students so they can learn at an early age how exciting it can be to study math, to study science, to see what it is that how they can contribute to society in the future. So by engaging students at an early age, keeping them interested, then they will be more likely to stay interested in math and science through high school and then on into college and consider pursuing engineering, which is based on science and technology and math, and pursue that as their career.
PLTW offers professional development to teachers by preparing them to implement project-based curricula in their classrooms. This hands-on approach is important to develop the skills necessary for students to succeed in STEM fields, allowing them to create, build, design, and solve problems.
There is a very high student success rate. It is written in a way and it steps through in a way that you can have very advanced students and very beginning students working together in the same class. The advanced students going further when they are ready, the beginning students getting retaught when they need it, but all of them getting skills that they can use.
Hilliard-Davidson is your typical suburban high school, I would say. By our second year of Introduction to Engineering Design, we had only about 8 to 10% female enrollment in the classes. And we found out that that was a nationwide trend. And a lot of the research that we had looked at had said things like the projects aren't interesting for girls, or they're not into math and science. And we thought maybe it wasn't that case because we had 1 or 2 girls in each class, and you could see that there was a discomfort at times because they're in there with a lot of guys, and sometimes there's that camaraderie amongst the guys and the girls maybe feel left out.
Anytime that I'm in like a math class and I'm with a bunch of guys, I don't feel comfortable like answering questions all the time.
When there are girls and guys, everybody's constantly worried about how they look or how they may appear.
So because of that, we thought that we would start a Women in Engineering course, specifically designed for an all-girls section of IED.
I definitely was more involved in all of the projects more than I would have been like group projects. I was able to communicate with the girls. And I mean, I can communicate with guys, but it was just so much easier to explain my opinion on a certain project.
In our first year, we went from an 8% enrollment girls to 24%, and then this year we're up to about 26% in our IED classes of female. What else is really good is our freshman class. About 40% of all of our freshmen are girls in our IED class. One of the things that we were even surprised a little bit about last year is that the girls were so comfortable with each other. And we asked them, why is it that you chose to take this course, and what would you recommend for girls in the future? And they recommended to take the all-girls section. They said partially because they didn't want to be the one girl in a class of guys and be the girl who just didn't get it. And so it was a comfort level on an issue.
By the time I get to next year's class with girls and guys, although there will be a little bit more pressure, I'll definitely know what I'm doing and be confident.
On the end of course test scores for Project Lead the Way, all of the girls passed. Their average score last year for IED was a 91% on the national test, and the boys' classes' average was about an 86. And so we were excited about that as well. We've only had 1 year of retention at this point. Of the girls that were in it, all but 2 took the next course. But what else is interesting is 5 of the girls in the class, after taking IED as a sophomore, chose to take both POE and DE as a junior.
I think that was just a good introduction. I understood the material and I was able to get down all the educational portions of it, and then the communication with the guys, it came easy because I already understood what I was talking about.
When we wanted to start the Women in Engineering class, we decided that having a college partnership would be important. And so we reached out to Ohio State.
This program has been around since 1973 to try to recruit and retain and place women in engineering career fields.
We've also had them come in and do specific projects.
We go over to Hilliard-Davidson and other high schools to help show younger girls what it's like to be an engineer.
It was very important to me to have that be that role model for them because I didn't have one. And it helps motivate them to see, well, if she can do it, I can do it. If she was able to go through those hard classes, then I can too.
And so over half the girls who attended that event ended up coming and joining Project Lead the Way and joining our IED Women in Engineering class because of their experience on that outreach with Ohio State.
The research shows that women are better at math and science courses in their high school years. They actually are comparable to where the boys are in those courses, but it's not translating to them coming into college and getting a degree in engineering. So doing something like Project Lead the Way in their classes, they can gain confidence. And that's really why they do or don't go into engineering.
Project Lead the Way definitely prepared me for the first-year engineering courses at Ohio State because I knew electricity before a lot of the kids there. I knew how to use computer animated design. I knew how to draw isometrically, and I knew a lot of principles of engineering that a lot of first-year students don't know.
If it wasn't for that program, I would not have gotten a degree in engineering.
All of the Project Lead the Way courses that I've taken have been my favorite courses by far. Like, I look forward to going to those classes.
They're mostly projects and there's lots of room for creativity.
I can be so creative in them, as well as using like educational skills like math and science.
We're excited about the fact that, like I said, over 40% of our freshmen are girls in our program. Almost every day we get emails about scholarships, opportunities for internships, and opportunities for unique in projects in college that they can take part in just because they're a woman who's in a STEM field.
I would definitely encourage other girls to study engineering because it's, first of all, a wonderful field. Second of all, you can pretty much solve any of the world's problems you put your mind to, which is part of the reason why I love it.
For anyone who's having troubles getting girls involved in their program, have no shame, have no fear. Tell your students to recruit girls. Tell them to tell their friends how exciting it is. But also make it interesting. Get involved with a local university or a local partnership and have events for middle schoolers that they could come to see that it's a fun class that they could enjoy together. And I do think that the all-girls section is a great way to take away that initial discomfort with the program, get the girls in and let them see how much they can enjoy engineering in high school.
I'm really glad that I took this engineering class, and I will definitely take the engineering class next year.
I'm definitely planning on going into some sort of engineering. I don't know what type yet, and that's kind of why I'm taking the classes. Now I'm discovering what type of engineering I want to go into.
Principles of Engineering and Introduction to Engineering Design, you actually get to apply those principles, which it helped me to understand actually more of where math and science would come into place and actually affect society.
I think it's the best thing I ever did in high school. Like, it's exposed me to so much, so fast, and it all makes sense. I think that everyone should take this. Like, this should be everyone's high school.
Project Lead the Way is all about relevance. It's the relevance of the study of science and math to a bioscience career, to an engineering career, something that's absolutely missing from when I went to school. And it is a great example of what we talk about when we talk about the relevance of education.
Getting a head start on their colleagues, whether they're entering the workforce or in college. I think that it builds a lot of confidence. It gives them some responsibility about seeing a project from its inception, development, and fruition.
It's amazing, and it flows well from what we do at home, because at home we try to do hands-on and apply everything that we're learning to real-life things, real-life situations. It's a seamless transition almost for homeschooling. It's perfect.
It's definitely living up to or past my expectations, because just all the projects are really fun and I like them. It's not one of those projects that's like, oh gosh, I have to come here and do this again. But it's one of those like, I'll take it home and try to make it harder than it is just to make it better.
I can only do so much as one person and as one teacher. And if you look at the resources behind PLTW, there's just a lot of people behind the curriculum.
The great thing about the Project Lead the Way curriculum is that it opens up that opportunity to work across all of our different programs.
And that's really our drive, it's our mission. It's what
we're really focused on is making sure that we provide as much access as possible to the 55 million students that make up the United States.
First, I'd say it's fun, because Project Lead the Way classes are fun.
I tell them that it's challenging, but it's definitely worth the work that's put into it.
Do it because you absolutely have nothing to lose, but you have everything to gain from this experience.
Selny's partnered with Project Lead the Way and the North Garland High School to promote the education for science, technology, engineering, and math in the Dallas community. It gives young kids an opportunity to get exposure to and make use of new, innovative engineering technologies in their schools.
My kids have been awesome, and because it's such a new program, the kids, they didn't really know what they were getting into when they signed up for it. They didn't know all of the pros and cons of being able to receive college credit. And so when they all got in here, they realized that it's more than they even imagined. And so my kids have worked really hard, and most of the kids in here really want to be engineers. So it's a great opportunity for them, and we've done a lot of fun projects in here, and I think they enjoy coming to the class.
We're building airplanes, and we're going to go, once we're all done building them, we're going to go out into the hallway, and we're going to see which one goes the farthest and lasts, or goes up in the air the longest, and have a little contest with it.
Before I started this class, I was thinking that I wanted to go into architecture, but now I want to go into engineering, and I hope to go to SMU for that. That's my goal.
Making me realize that I can build something on my own without somebody helping me, and I can figure out ways to build it, and I can just be independent.
Selny's contribution was amazing. Within Project Lead the Way, they assign us a supply list that we have to purchase before we go to training.